Okay guys, so let's proceed with the second question, 8.1.2 from the previous session where I was explaining what is the meaning of Ohm's law. So we're gonna do from 8.1.2 until the last question. So the second question says calculate the total resistance of the external circuit. So what is the external circuit? So external circuit on this one, when they say external circuit, they mean the external circuit, they mean the combination of all the resistors. So when they say external circuit, they mean total resistance, R total. So remember, R total you can calculate it by starting with the parallel resistors. So when you calculate R total, you have to start with the parallel resistors. So in order for you to do the R total here, as you can see, you've got these two resistors that are parallel. So you can say it's R parallel. I'll just write R parallel. That's the total of those resistors plus R series. R series is this one. This one is in series with the circuit, but this one is RP. RP meaning R parallel. So you're gonna have to find this parallel circuit and also the series one. The series one is already given, so you can say R total is equals to R parallel plus R series. So now you need to know the formula for calculating parallel circuit. So we're gonna start with parallel. So for parallel, we're gonna have 1 over RP is equals to 1 over R1 plus 1 over R3. So it's these two. So this one is R1 and then this one is R3. So you're gonna have 1 over 2 plus 1 over 6. 1 over 2 plus 1 over 6. This is how you do the parallel circuit. Then let's bring the calculator there. So you're gonna have 1 over 2, then say plus 1 over 6. This will be equals to, let's write it in a decimal form. Let's write it in a decimal form. So okay, so you can write it as, let's write it like this, 2 over 3. Then remember, it's 1 over RP is equals to 2 over 3. We don't want 1 over RP, we want RP. So in order for you to get RP, so you're gonna say RP is equals to 1 over, you see, 2 over 3. So this is how you remove this one. Or you can simply do this, cross multiply. So alternatively, you can cross multiply. So you cross multiply there, you're gonna have 3 times 1 is equals to RP times 2. So you do this, you multiply this with this, this with this. And then you're gonna have RP is equals to 3 over 2. So if you punch 3 over 2 on the calculator, you punch 3 divided by 2, then you should get 1.5. Get 1.5. So you've got 1.5 ohms remember to write the units. If you don't write the SI units, your answer is wrong. If you don't write the SI units, your answer is wrong. So this is how you do the parallel circuit. This is how you do the parallel circuit. Then we move to the next question. Let's move to the next question. So this formulas, in case if you forget the formulas, this is where you find them. This is where you find them. If you go to the formula sheet, you will see 1 over Rp. Then the series one is that Rs. In case if you forget them, you just go to the formula sheet. Your question paper will have the formula sheet. Okay, so let's do the next question. So the next question says, calculate the internal resistance of the battery. So the internal resistance R, the small r, this one right here. So we want this R. We want this R of the battery. Remember, in order for you to calculate the internal resistance, I'll just say C, internal resistance. Internal resistance. It's a small r, the resistance of the battery. So the internal resistance, in order for you to calculate it, always the formula says EMF is equal to, this is the formula, IR plus IR, small r. Remember the internal resistance, the I is always in series with that. So you can simply say I is the common factor, then you do this. Say R plus R. So remember this R, this one, that R is for external resistance, total external resistance. And remember previously we just calculated the parallel one. So to get the series one, we just add, we'll just combine them. So because there we need the total external resistance. So R total is equals to Rp plus Rs. So already you know what is Rs. So we're going to say 1.5 plus 3.5, your Rs. That's your R total. So it will be equals to 5 ohms. That's your R total, the total external resistance. So to calculate internal resistance, you need the R total, the external resistance. So you can't calculate R without knowing what is the total resistance. Then I is also your total current. So remember they already gave you the current. So you know current, you know your EMF. Your EMF is here. They already told you that EMF of 12 volts. So it's easy, you've got everything. So you're gonna say 12 volts is equals to I. What is your I? Your I should be 2.2. Then you say open bracket, you write 5, your external resistance, then you say plus R. That's what you're looking for. So here you need to apply maths. You need to apply your maths. You're going to say 12 divided by 2.2 is equals to 5 plus R. Then you're going to say 12 divided by 2.2 minus 5R. Then equals to, is punched on the calculator. So you're going to have 12. Okay, sorry. So it's 12 divided by 2 0.2, then you say minus 5. This will be equals to 0.45, 0.45, 0.45 ohms. This is your internal resistance. This is the internal resistance. That's how you calculate it. Okay. Or there's the alternative method. Or so remember you've got. Let me show you. So alternatively, in case if they didn't give you enough information, let me show you what we can do. So the internal resistance, we can calculate it this way. Remember, you need to know your external resistance. So you see, they already told you the V. You see, V1 has a reading of, so you need to know the V1. So V1, you can name it as your V external. So you've got external voltage across that battery. That's your external voltage. External voltage. Then you've got the EMF. Then you've got the internal voltage. So internal voltage will be across this internal resistance. So you've got V internal. I normally refer to this as a V loss. So you've got internal voltage. So what you can do, since you know your voltage there, you know your EMF, and then you also know your external voltage. So let me tell you something. I'm going to show you something. Remember, you've got EMF. The formula says EMF is equals to, right, I R plus I small r. Remember, this is external resistance. So what is I times R? It means it's V external. Then this means V internal. Remember, it's you're multiplying current times the internal resistance. So current times resistance is voltage. So you see, since you are multiplying the first current, this one, since you are multiplying it with the external resistance, so it will be external voltage. And this one, since you are multiplying it with internal resistance, it will be internal voltage. So you can use voltages. So since you know that the external voltage is 11 volts, you can simply use this. You can simply use that. You can use it. Okay, so you already know the external voltage. So you're gonna say 12 volts is equals to 11 volts plus, what is your I? Your I is 2.2 times R. You see? Then you're gonna take 11 to the other side. You're gonna have 12 minus 11 is equals to 2.2 times R. And then your R will be equals to 12 minus this, you're gonna get 1 divided by 2.2. Then if you punch this on the calculator, you will get the same answer. So you're gonna have 1 over, so you can say 1 divided by 2.2. You see? So you're gonna get the same answer, 0.45. So you're gonna get the same answer. And that's how you do that question. That's how you do that question. 0.45. Remember to write the ohms. So it will depend on what you're given. It will depend on what you're given. Okay, so we move to the next question. So the next question say calculate the reading on V2. So we need the voltage across V2. So we need the voltage across this V2. So remember the total, in order for you to calculate V2, remember now we have got one resistor here. Here we have got one resistor. We don't have R parallel now. We have got RP is equals to, we have got one resistor there. We have got that 1.5 there. So now it's like you've got this resistor and this resistor. You've got RS there, 3.5. Then you also have the RP there. So you've got two resistors. They are connected in series, you see, and the ammeter is there. So meaning the current is the same. Since they are connected in series, the current is the same. Okay, so the current is the same. So now to calculate the V2, you have to use this current. You have to use that 2.2 current. Okay, so V2 will be equal to, remember, you have to say I2 R2, because we are calculating for that specific resistor. You have to use that resistor. We are not doing for everything. We are only calculating for that resistor. So that's why I'm choosing R2. So what is the current through R2? The current that is flowing through R2, since it's a series circuit, is the same. It's that 2.2 because it's series now. So I've got 2.2 times 3.5, right? Then your voltage is going to be 7.7 volts. So you can calculate it with this calculator. So you can say 2.2 times 3.5. 2.2 times 3.5. Then you're going to get 7.7 volts. See? Okay. That's how you do that one. Then there is some alternative methods that you can use. There's alternative methods that you can use. But for now, let's just use this one. Okay, then let's go to the next question. So the next question says, calculate how many joules of energy the battery supplies to the 3.5 volts in 5 minutes. So they want the energy, or we can say, yeah, it's energy in joules. So they want energy in joules. So what is the formula for energy? We need to identify the formula for energy. So let's go to the formula sheet. So if you go to the formula sheet, you will see there's a formula for energy. There's a formula for energy. So it's W. So we are going straight to this W. That's where your work is. Remember, energy is work. So that's where we are going. So we're going to choose a formula that we can use. So let's choose one based on what we have. So do you see that energy, remember it's W. So you see here, we've got this one. We need to consider the one that has got time. Remember they said in 5 minutes. 5 minutes. 5 minutes. So you need to consider the formula that has got work or energy, like this one. W means is energy. So you need to consider the formula that has got time and energy. See, even this one has got time and energy. Even that one has got time and energy. Then, so before I can do this, remember, you see the power is equals to VI. That's why the power is equals to VI. So if you substitute power there, let me do this. If you substitute power there, P, it will take you back to this formula. These two formulas are the same. So the two formulas are the same. So you're going to have W is equals to P change in time. So it's the same. So you see, I would prefer to use this formula because I already know my voltage, I already know my current. I already know current and voltage and time. So you see, I already know these three. So there's a lot of formulas that you can use. You can use any formula. So look at this. Do you know your R total? Total. Yes, you know your R total. Do you know your total voltage? See? Do you know your voltage? You need to check those things. So let's see, what do they want? Okay. Do they specify where they want the power? So they want the power where? You need to know. So you need to know your power. See? So the question says supplied by the battery to the, so they specified the resistance, you see. So this is your R2. So we can say it's R2 or RS. So you need to use the V2. If you want to do this one, you need to use V2 and I2 if you want power. Remember, power is equals to IV. So if you want to use this one, you need to use the values of that specific resistance. So for example, if we decide to use W is equals to I V change in time. If we decide to use this one, remember this you need to use the V2 and I2. I2, remember, it's the same, so it doesn't matter. So that the V2 is this one. That's if you know it. If we didn't know it, we're going to use the alternative formulas. Remember, P can be, remember P is IV. Let me show you how to change this formula. So remember, power is equals to IV. It's a standard. So power is there. You replace that IV with power. Then what is V from Ohm's law? V is equals to IR. So do you know that we can substitute V there? Instead of writing V, we can write IR. Then we keep the same R. So you're going to have I into IR. You see? In case you forget the formula. So you're going to have I squared R. And then P again. We go to the same formula. We are done with V, ne? So we go to I. What is I? This I in Ohm's law. So I in Ohm's law, so we're gonna go back to the formula for Ohm's law. We're gonna say I is equals to V over R. See, you take V over R there. So you're gonna say we replace I. So you're gonna put V over R, open bracket, times V, then the original V, this one. Then you're gonna have P is equals to V squared over R. This is what you're gonna see on the formula sheet. That's how they got it. Then, so meaning from our formula W is equals to P change in T, we can substitute any of this. So we can substitute this one, this one, this one. So you can substitute 3 times. So it's 1, 2, 3. It will depend on what you have. 3. It will depend on what you have. So let me teach you something. So I normally prefer using the values that was given originally. I prefer using the values that were given originally. You know why? Because sometimes, let's say you got your V2 wrong. That's 7.7 volts. Let's say you got it wrong. If you use it there, it means you're going to get 2 answers wrong. So I prefer using the original data if it's provided. Like you are given I and then you're given R. They are given. So use the given values in case if you got the previous one wrong. So we're gonna use this formula where you've got I squared and R. So where there is W, we're gonna say W is equals to I squared R times change in time. So that's what I'm gonna use. So I already know that I've got 2.2 squared. I'm not saying the other answers will be wrong, but in case, if you are sure, then you can use that 7.7. You will still get the same answer. So you're gonna have 3.5. Then the time they said 5. So we're gonna do that. So if you multiply this, let's multiply. Let's multiply this. So you can have 2.2 squared, open bracket, 3.5 times 5. Okay. Remember they give you time as well. You're gonna have this 84.7. You're gonna have 84.7. Remember your time is given in minutes. Then that's 5. So your time is given in minutes. Where's the question? So your time is given in minutes, and then we don't want time in minutes. You should always change it to seconds. So you need to change that to seconds. This need to change it to seconds. Remember, seconds will be more. So since seconds will be more, you multiply it by 60. So you have to change it to minutes. You can just multiply. You can just say times 60 to change. Remember, everything is multiplied there. So everything is multiplied. Then you get 5082. We are not done. 5082. Okay. So it's 5082. Let's write it down. W is equals to 5082. So what was this? That's 5082. It's 5082. So it's 5082, your final answer. 5082 joules. Remember to write it in joules. So you don't have to write it in full, you can just write J. Remember to always change time, change T to seconds by multiplying by 60. So you don't use it as minutes. You have to change it all the time to seconds. So other formulas. So you can use this formula. IV change in time. You can use this formula. So you'll have 2.2 times 7.7 times 60 times 5. You will get the same answer. You can use this formula. So let's make this calculator. So you have 2.2 times 7.7 times 60 times 5. See? Get the same answer. 5082. Okay, that's all for this question. Then let's go to the next one. Thank you. should be the last question. Should be the last questions. So you've got 8.2. 8.2 says the switch is replaced with a high resistance nichrome wire. Switch is replaced with a resistor. How will the temperature of the battery be affected? So remember, if a switch is replaced with a resistance, let me tell you something. A resistance affects your circuit. If you the moment you connect resistance, the moment you connect R in a circuit, remember resistance limit current or reduce current. So the more you put resistors, it means you're gonna reduce current. So what will happen if you reduce current? Let's go to this. So the more you reduce the current, meaning there won't be more electricity. Remember, the more the electricity is, the hotter the more energy is generated. Let's put it that way. More energy is generated. So if more energy is generated, the temperature becomes higher. You see, if there is more energy generated, the more the temperature gets higher. So if the current is too low due to resistance, then the temperature decreases. So the more you put the resistors, you limit the current, meaning there is no current flow in that circuit. There is less current flow. Then the lesser the current flow, the temperature decreases. So the answer for this one is decrease, because the moment you put more resistors, the more the resistors, the lesser the temperature. Remember this, as current flows through a circuit. Resistance limit current. So current is your energy. Take it as energy. The higher the current, the more energy. More energy, higher temperature. And then higher resistance, lower current. Yeah. Resistance is like a wall. It's blocking you. It's blocking the current. Okay. And then the next one says an electric appliance is marked 240 volts. So this is your voltage. And then 2000 watts. It's your power. Electricity costs this much kilowatts per hour. Calculate how much it costs to operate this appliance for 2 hours. Okay, so they want to know the cost. So how do you calculate the cost? Let's go to the formula sheet. How do you calculate the cost? So your formula sheet will provide you with everything. I'm gonna give you the formula for cost, but since you know your power, you know your voltage, so I'm gonna write down the formula. There is everything. Is the question. Okay, so they want you to calculate the cost. So the formula for cost is, please write it down, is C is equals to tariff times E. Okay, so I'm gonna explain this just now. So this E is the energy, so you have to calculate it. It's this. So you need to calculate that, because the tariff they already gave you electricity cost. So tariff is the electricity cost. You see, electricity cost. This is your electricity cost. That one, electricity costs. And then this one is the one that you need to calculate. So this one is the one that you need to calculate. It's your energy in joules. That's your energy. Energy, remember, it's in joules. So remember, it's the same as W is equals to that formula that we're using, P times, remember they gave you time, T. Remember they gave you time. So look at this. So look at this. They gave you time and then they gave you power. So you see, your given time is 2 hours. Then what is power? The given power of 2000 watts. So look at this. Look at this. So your energy cost is in kilowatts per hour. So meaning your energy as well must be in kilo as well. So this is what we're gonna do. Let's calculate this. W will be equals to, what is P? P, you are given the P there, it's 2000. It's 2000. Then they are given 2 hours. So look what I'm gonna do. I'm gonna write 2 because already here it's given in kilowatts. Already it's given in kilowatts. So I don't have to write 2000 because already a kilo is 1000. So you divide that by 1000. You divide it by 1000. So you just write times 2 hours. So because already you see even this one. You see even this one. It's kilowatts per hour. So it's 1000. Here already you've got that kilo, which is 1000. Then you've got hour. So you don't have to convert it because it's already measured in hours. So you don't have to convert this to seconds or minutes because already your tariff it's kilowatts hour. So even this one must be in kilowatts hour. So if you want to convert it to kilo, 2000, that 2000, I'm converting that 2000 to kilo so that I can have this as a kilowatt hour as well, right? So remember, you're calculating this. This is a power. Power is measured in watts. So in order for you to have kilowatts, you divide it by 1000. So you're gonna have kilowatts. Then here you're gonna have 2 hours. So I want to make them similar so that I can multiply the two. So this must be measured in kilowatts. So I am multiplying this. W is equals to 2. We divide there, you're gonna get 2. So this will be 4 kilowatts hour per hour. So your cost will be 1.2. So this is how much the tariff, like maybe per kilo, per kilowatts per hour. This is how much you buy it for. Then you multiply it with the you multiply it with your work or energy. So you multiply it with 4, you're gonna get, let's calculate this. So you're gonna say, let me erase the calculator. Okay, so you're gonna have 1.25 times 4. Then you're gonna get 5. So the cost will be 5 rands. Would be 5 rands. This is how much it's gonna cost. Okay guys, thank you for watching. If you do have any question, please send me a text. I'm gonna leave my WhatsApp number and also the link for the session. Please comment if you have any question. Thank you.